We're now going on a time journey, and I'm pretty sure that most of you has been involved in similar time journeys or projects will recognize yourself. It all started in 2022 in May, and here on the picture you see a stick that marks the place where we're gonna drill for groundwater. The reason for this is that in the house we are living at, the water during summertime basically stops coming to a well. So during the summer month, we don't have any of our own water. We have to take a drive to collect water from the municipal. Before we put the stick down, we made some thorough investigations in regard to the ground conditions. We looked at scientific data for this area, but we also used the old-fashioned method by calling a person that could use a wooden stick to find where water could be. And when we compared what the person said compared to the data and what we could get from the scientific part, we matched this to that exact point where this stick is located. But one very important thing, you don't start drilling for groundwater without a permit. So in May the 15th, we applied for a permit where we stated why we want to make a drill hole in order to get more groundwater to be self-sufficient during the summertime as well. And we sent that to the municipal and we got an acceptance for starting this journey. After the summer, in September, the drilling rig arrived, which you can see on the left-hand side picture. And on the right-hand side, you can see how we now started to drill down. And based on the research we did before putting down the stick, we stopped at 17 meters with the drilling. After the drilling, we started to test pump. We took water analysis of the groundwater well. What we found was that the recharge was very slow, but it did recharge all the year. So we had a water source that we now could complement the old water source to our house. So based on that, I did the process design that you will see later, and also you can see in my previous videos. But we started now preparing for the place where we're gonna put the waterworks building. That is what you see here on the picture. Also, if you look carefully, you can see a yellow hose down here. And that's of course preparation to get the electrical cables to supply electricity to the new waterworks. Here you see the new waterworks building taking form. One of the things we were very careful about was the insulation. So the waterworks building is very well insulated, and that is of course mainly for winter time, but of course also for the summer times when the temperature gets elevated here. We also made a decision not to have any windows on the waterworks to basically be able to insulate all the areas except for the door. So in June 2024, about 2 years after the start of the project, we got the waterworks building delivered to site, as you see here in these two pictures. One thing you should note is the door of the waterworks building, and I'll show that with my cursor here. The door is in two parts, so you can open it up wide, and that's something that's important when you should take bulky things in and out of the waterworks. In our case, we had a hydro press, the pressure tank for the water after it's been prepared for drinking water. But as a general rule, never take too small doors. Here you see us working with the outside of the waterworks, painting it white. And of course, white is to minimize the heat absorption of the waterworks, especially during summertime, of course. Also here in the pictures, you can see the height of the wall where we're gonna place all the process equipment. Here again, it's important to have good space. And here also, I'll show you with the cursor again, you can see the door opening that I mentioned in the last pictures. After the painting was done, it was time to hook up the electrical feed to the waterworks. Here on the middle picture, you see a very good friend who helped us with the electrical. And also you see the yellow hose that I talked about before and the electrical cable that now is going to supply the electricity to the waterworks. On the left-hand side picture, you see the same cable coming up to the hookup point to the grid for our houses. And to the right-hand side, you see the first cable coming into the waterworks. One of the very important things in a place where you're going to work or produce something is good lighting. So after we got the hookup for the electricity, we installed very good lighting in the waterworks. And here on the pictures, you can see that we use 4 big lights to illuminate the space for the waterworks. After getting the lighting in place, we started to set up what you could call a mock-up of the process design. Here on the picture to the left, you see some brown cardboard paper which simulate the electrical cabinet, and on the cardboard you see the PLC screen. So this is the estimated space for the cabinet housing the PLC. Beside that, you see the control unit for some of the sensors. And here on the wall, you can see piping, you can see sensor placement, valves, etc. And the pictures to the right, you see more in detail the setup on the wall with the piping, and also the section of the process design that would be placed on the floor connecting to the hydropressure or the pressure tank. And doing this gave us a very good idea on how to mount everything, mount the hardware. Also, how should we get the electrical wire all the way to the electrical cabinet in a good order. So now we are about 3 years in the project, beginning of 2025. Here on the left-hand side, you can see how we now have moved the PLC, the electrical cabinet that now has been fabricated, into the waterworks. And on the right-hand picture, you can see the mounting of the electrical cabinet with the PLC. Now, for those of you who notice it, on the mock-up, the space or the area for the electrical cabinet was somewhat smaller. However, when we started the project planning process design, we made certain that we always took a little extra space. So, as you see, when the electrical cabinet came up, it worked very well. So, in April 2025, the work with mounting all the instrumentation and process equipment starts. In October, we're starting to mount the PVC piping, and I had help from a very good friend doing this because getting the PVC piping in place and correct is a challenge and need to have skilled people doing it, because here you glue the PVC piping. So once you have glued a joint, it sticks. So you need to be very careful in the making and setting up of the piping system. But here you see some pictures from when it's about 60% done with the piping in October 2025. In November 2025, we started to hook up all the electrical wiring and cables from the process to the electrical cabinet and, of course, the PLC. On the picture here, you see the PLC and also my good friend that did the PVC piping also. He's not only good on that, but he's also a very skilled electrician. Now, on the pictures to the right, you see all the cables in place. But here it is important to note that we are talking tens of yards of electrical cables going together, going into the PLC. So planning the setup of the cables is very important. This, of course, my friend knew and he experienced in that, but also, as I said before, for some slides ago, setting up the mock-up in order to plan both where the equipment should be and how the cables should be put is, of course, very important, and now it benefits us when we're doing these final work for the waterworks. After the completion of electrical installation, we started to upload the PLC program, and the programming had been done by also a very good friend of mine, and you can see him on the picture to the left. So now he is uploading the first version of the program. Also on the right hand side you can see the HMI. That is on my own computer. Also, along with the PLC startup, we also created an internal web so we could access the PLC from our little house. So after 4 years from the start, where we picked out the place where to drill the borehole, we now have a 98% finished waterworks. And to the left hand side picture you can see all the equipment. You can also see a table or a desk for a small operational lab that we are going to have. Also, we have started putting in some sensors in the borehole, also preparing the pumps that is now soon going to be installed in the borehole. We'll get to that in a minute. Also in April, we started to dig for the piping from the old well that we're also going to connect to the waterworks. And we did that in April in order to have prepared so we knew exactly where the hookup point for the old well was. But just to be clear, what the work we're doing now and the startup of the waterworks is with the new borehole, the new raw water source, so to speak. Last month we dug out for the water piping, the cable for the level sensor, and also for the electrical supply for the borehole pump. Here to the left you can see it was quite a challenge to dig the grave here, as you can see, close to buildings and constructions here. Also the ground is very hard, and probably you can see the stones that are being dug up as we go down to the depth of 90 centimeters to have it frost protected. Also, you can see here in the middle pictures, you can see the grave, the finished grave, and also you see the black hose. That's a 25 PEM hose for the water from the bore to the waterworks. And here you can see the borehole, the protection piping, and here you see the connection from the pump in the borehole to the hose towards the waterworks. And on the right hand side, as I said, we dug down to 90 centimeters in order to be safe in regard to freezing, but also in order to have double safety, we also insulated the PEM hose, as you see here on the picture to the right. On the left hand side you see now the water pipe, the PEM 25, and you see the welded joints when we go from the grave into the waterworks. And here you see the electrical heating cable that will be put alongside the water piping, and the yellow protection cable for the electrical cable to the pump and the level sensor. Here you see the PM25. If you look at the cursor here, it's coming into the waterworks, starting to feed into the process. And the middle pictures here, you see us refilling the grave here. Also, you can see it's, the grave is now refilled. And you can see the yellow protection cable ready to get the cables over from the borehole. And also you see the insulated PEM25 with the insulation around it. Also, you can see here the electrical heating cable around the water pipe. And here to the right hand side, the work around the borehole for having the pump down, getting all the cables up. And finally, the pictures down here, you see now the pump is down in the borehole, and here the pump's electrical cable is going up. And here you can see the connection point for the electrical. So here you have a socket where you connect the pump, and then you have a new cable going in towards the waterworks through the yellow protection cable. Now the pump is down in the borehole, as you can see here to the left hand side. You see the blue cable, that's the electrical wiring for the pump, and the green cable here is the level sensor that now is down in the well as well. And here you see a bucket where we had sodium hypochlorite solution in order to make a preventive disinfection measure when we lowered everything down in the well, because the cables, the water piping was on the ground before we put it down in the well. So we had hypochlorite as I said, as a protective measure. Here on the middle picture, you see the complete installation. You see the yellow protection hose where you had the electrical for the pump and the level sensor. Here I cut in a small picture of the old lid before we did all the installation. So that's like a memory lane picture. Here you now see the insulated water piping, as we discussed before, going into the waterworks with the electrical heating on. The yellow protection cable with electrical and level sensor cable. Now to the right hand side, we needed to do cleaning up of the well, because when you lower the pump down, it will stir up fine particles, or as we say in the business, the turbidity will go up. And before we took the process into operation for the startup, we wanted to have a clear water. So basically what we did, if you look at the right hand side picture here, so we pumped the water in manual, we started a pump, pumped the water this way, and we shut off the process after the microfilter, so the water came out here. And then we measured the turbidity constantly. And when the turbidity was below 5 just about, then we said, okay, the fine particle is gone from the well, so now it's ready for the startup of the actual process. And just a comment, the turbidity measurement here, 29.2, is very high. And that we aimed for below 5 before we open up to the process. So now we have a clear water, and before we now start producing drinking water, we also wanted to disinfect all of the plant, all the piping inside the waterworks. And we did this by basically, if you look at the left-hand side picture here, you see a tank of water. It contains about 520 liters of chlorinated water. And we set the chlorination to 40 milligrams per liter active chlorine. And the solution is, of course, sodium hypochlorite. So from that tank, we fed by gravity, if you go to the picture here, where we fed this by gravity, you see the blue hose. So the chlorinated water, and we took down in the borehole. And all the duct tape and stuff you see here is actually just to protect the electrical sockets that we connected the pump with, as you saw in the pictures before. So the chlorinated water went down, and then we pumped the water through the waterworks. So all the piping, pressure vessels, sensors were disinfected now using this system. So we pumped about 520 liters through the system, which is about 10 10 or 15 times the total volume of the waterworks equipment. And here you can see the water process, or part of it. And now it's important that here, if you remember the last picture, we took the bypass water here to clean up the fine particles, the turbidity from the borehole. So that is of course shut off now. So the water is now going through the process over here, and you can't see that, but here it comes back. Here you have the pressure vessel to feed the drinking water to the houses. And now down here you see the new point for taking out the water. So basically we pump through the chlorinated solution, and here to the right hand side you can see the blue barrel. So the water was pumped over to this, and then of course we reused as much as possible of this water, of course. And in order to check the chlorination, we measured constantly the concentration of free chlorine in the water, and that's the picture you can see here to the right. So we have of course a protocol where we put down the measurements, time and volume, so forth and so on. So when this was done, we were certain that all the piping in the waterworks were now disinfected, and the waterwork was ready to start up and test the functions, so forth and so on. Now, the 29th of June, the borehole was connected to the waterworks with all the steps I have just told you about. And the turbidity of the water that is now being produced from the borehole is about 1.7, or more correctly 1.68. So that's very okay. Also, on the picture to the right hand side you see an overview of the waterworks today with a small operational lab that we also have. And as I mentioned before, that the next step will be to connect the old well to the waterworks in order to distribute drinking water to our house. So with that, I thank you and hope you enjoyed the video. And as I said, there will be a sequential when we now connect the old well to the waterworks and our houses. Take very good care and have a beautiful summer. Bye bye.